Hi, in this video we're going to talk about how to program Rust into Arduino Uno board. So this is basically embedded Rust, and specifically we're going to see how to take Rust and put it into Arduino and use Rust as a language to code and program the Arduino board. And as the first step, we're going to blink an LED. So my current system setup is that I'm using an Ubuntu OS and I'm using VS Code to sort of type the program and put it into Arduino board. So along with these two or any other text editor like Sublime would do other than VS Code, but along with these two we need a couple of other software and cargo packets, and I'll tell you about that. We need to install a couple of libraries first, one of them being ravedude crate, which is going to help us in cross compiling. So since I have an Ubuntu machine and the code that I'll be writing should be programmed into an Arduino board which has an AVR chip that is Atmega 328P, which is an AVR chip. So we need to do cross compiling. So to help us with that, we could either use AVRdude or we can use ravedude. Ravedude is a crate that is built around AVRdude. So we need to use that, and we need to use something called as cargo generate to generate the code. So amongst the methods that I have seen, I think this is one of the simplest method to program an Arduino board, Arduino Uno board with Rust. So first, of course, we'll need Rust. To get that, you need to go to the Rust official page, Rust lang page, and get started. So here we get a command. For me, installing Rust on an Ubuntu machine is very easy. I just have to go through this command, paste it, and Rust will be installed. So you'll have to set up Rust and then continue with this project. So here I have, so since I'm programming an Arduino board, I'll need something called as HAL, that is hardware abstraction layer. This is going to help me the Rust code compile it down into a way that the Arduino board is going to understand. So this is the embedded HAL abstractions for AVR microcontroller board. So we'll have to use this GitHub link. Here they have given a quick start, what we need to do and the steps that we need to follow essentially to program our Arduino board. So in an Ubuntu machine, we'll have to type this command to get the essential libraries, which is AVRdude, which is a package that is AVRdude. So let's open terminal and I'm going to paste this command. So it's going to ask us for password. So since I have already installed this, let me maximize that and increase the font a bit. So since I've already installed that particular package, it has shown as 0 upgrade, 0 newly installed, and 0 to remove. But basically you'll have to type in this command, which is already provided in the quick start in the GitHub link. I will provide that link in the description below. So you follow through that command and you make sure that this package is installed. So after we do that, this is the case for Ubuntu machine. If you have a Mac OS, you can follow this command, or if you have Windows, you can follow this command. So next what we need to get is a ravedude. So let us do cargo install ravedude. Before that, we can take a look at what ravedude does exactly. Here we see that ravedude is a crate, and this is a command line interface utility that is made, that essentially makes Rust development for AVR microcontrollers very easy. So we can think of this as a cross-compiling platform. Essentially, when we're programming an Arduino Uno board, we using C or C++, we might have used Arduino IDE, which is an integrated development environment provided by the Arduino. So by using ravedude, it becomes very easy for us to program this. That is essentially after installing ravedude using this command, cargo install ravedude, that I'm going to copy right now. All we have to do is build and run. So it becomes that simple. So we need to install ravedude. So I have copied the command. So now that we see that ravedude is installed, the next step is to install cargo generate. So let us first take a look what cargo generate is and what it does. So here I'm in the GitHub page again of cargo generate, and cargo generate is basically, it is a developer tool that helps us to set up the Rust project using a pre-existing Git repository. So the concept is that we already have Blink LED examples, many of them online, few of them in the form of GitHub as well, few of them uploaded to GitHub as well. So it is pretty much very easy to take that code and put it into our board instead of using complex methods to download and install several packages and all that. So that is where cargo generate comes into picture. We can take any GitHub link, and after installing cargo generate, of course, we can take any GitHub link. A project folder will be directly created for us in the editor that we're using, in our case VS Code. So I'll have to copy this command, cargo install cargo generate, and I'm going to paste the same in the command in the terminal. So here I see that I have already installed cargo install cargo generate, so it has ignored the command. The next step is to take the GitHub link and paste it here so that a project folder will be generated for us. So I need to take HAL template link, this link, and I need to give it into the command prompt in this way. Cargo generate -- git and the GitHub link that we have, and I hit enter, and it is going to ask me for a project name. I'm going to give it as Arduino LED Blink, and because of used caps it has renamed it to Arduino LED Blink, all in small, and it is going to ask me which board that I am using. I'm currently using Arduino Uno, so I've selected that. It is selected by default, and you can navigate through different ones and select the one appropriate for you and hit enter, and a new project has been created already, and this is the path. Now I need to navigate to that path. So I'm going to type change directory cd and hit enter. Now that I am in that path, I can open my VS Code, that is code space dot, and it opens me a VS Code where a cargo folder with config toml file and all the board JSON files. For us we'll be using 328p, but all of them, along with my source file, main file, and Rust toolchain toml file, cargo toml file, all of them is already there, cargo toml and main.rs. Let us understand the code a little later. Let us first see what all of these directories basically mean. So dot cargo folder we have because we're using cross compilation, and in simple terms, config.toml file is going to tell where our target is going to be, and here we see that the target for file name would be avr specs avr at mega328p.json. So if we go to that target, here we see that there is a here in avr specs folder we see that there is 328p file. So config toml file is going to tell that the specifications of the board that we're using would be in this target file. That is what the config toml file says, and the target file would be here at the particular mentioned address, and this JSON file is basically going to contain the type of board that we're using, type of CPU that is there, and how many bytes it's going to be, and what is the executables and all that, and is going to generate as an .elf file. So we have config.toml file. In the source file we have our main file where we actually have the code that we need to blink the LED, and in the cargo.toml file we have dependencies listed. What are the dependencies that we need for our project to work is listed in the cargo.toml file. So to understand this a little bit better, what does the .cargo folder and the config.toml file, source, main, and the cargo.toml file, there is a diagram that depicts it properly. So we have in the main root cargo.toml file and source file, and the source file contains the main file. If we were using any libraries, even that would be a part of the source file. So cargo.log file is something that is generated by the compiler. So here we see that that is the same case for us. So let us now see what is the code that is actually written. Here we see that there is no standard and no main as the first two lines. It basically means that there is no standard that we're using and there is no main function that we'll be using. This is the case because this is bare metal coding and there is no OS. That is the reason. Because there is no main function, we need to tell when is the entry point at the program, and this does that for us. And we need to also use a panic halt case in case the program panics. What should it do? If the program is not behaving the way we intended, then panic comes into picture. So here we're initializing the peripherals, and because take is an option, we need to unwrap it. And here we're initializing the pin that we'll be using. So here we see that we have used LED pin number D13. This is the pin number that is there, that has the LED on the board. So we'll be using that, and we're declaring that as output. And here we're using LED toggle function to switch between the off and the on state. Between that we've provided a delay of 1000 milliseconds. So if we just control click on toggle, it takes us inside the function to tell how is it actually working, how is the API actually written. So this is the toggle out function, and how we can toggle a pin from high to low state and low to high state. So anytime there is a code written and we need to know more about it, we can control click on it and it takes us in there. How is the delay function working? We get to see that here, we get to understand that here. That's a useful technique. So we can also see in the Rust Lang book, the embedded Rust book, in the program overview, we get to see how the structure usually is for embedded programming, and they explain what no standard exactly does that. So there's no standard crate std, so instead of that we're using a subset, that is the core crate. And no main means that there is no standard main interface. So we need to say that in the beginning that there is no standard and no main, so that Rust understands that this is embedded Rust and that will be doing bare metal coding. So this use panic halt crate provides a panic handler that defines the panicking behavior of the program. So at the point where our program does not behave the way we want it to, the program panics, and the panic handler takes care of what happens then. So we need to use this statement at the beginning. So this is the entry point. We're not using a Cortex M board, we'll be using AVR board. So this is Arduino HAL entry. So this is about the program that we have written. After this part is done, we can go ahead and put this program into the Arduino board. Up until now, we saw how to generate the program and how to set up the environment. So now we can actually go and put the program into the Arduino board. So to do this, first we need to build our program. So I'll open a terminal here. and I'm already in the folder. Now I'm going to go ahead and do cargo build. If I hit enter now, it is going to build, but if I hit space -- release, it's going to give us detailed debugging information. It is going to generate a file that will be like 2 MB or 3 MB, a higher memory size, but it is going to give us a detailed debugging information. So that will be helpful if in case our program goes wrong at any point, we can refer this. So I'm going to do cargo build space -- release, and it is compiling. And building. So at this point, Rust looks at all the dependencies that our program has and goes ahead and installs by itself. So we don't have to do much. After building successfully, I'm going to plug in the Arduino board to the USB port. And I'm going to select the device. After that, I can go ahead and type cargo run. Even now, I'm going to do space -- release. I'm going to hit enter. I deselected the plastic. So we can see that the chip is flashing and it's blinking the LED. So this is how we blink an LED in Arduino Uno using Rust. I'll provide the necessary link in the description below so that you can go ahead and learn more. Thank you.